Humanity has always looked up, captivated by the celestial tapestry above. From the earliest campfires to modern cityscapes, the night sky has been a source of wonder, inspiring myths, legends, and a deep-seated curiosity about what lies beyond. Wondering about our place in the vast expanse. Are we alone? What is the fate of the universe? These fundamental questions have driven our exploration of the cosmos for millennia. For centuries, our eyes, unaided, were the only windows we had to the universe. And then telescopes brought the universe closer, revealing details previously unseen and sparking a scientific revolution. These instruments allowed us to peer deeper into space, but they were still limited by the visible spectrum. But the James Webb Space Telescope, JWST, is something else entirely. It represents a monumental leap in our ability to observe and understand the universe. It's not just another telescope, it's a time machine capable of looking back at the earliest moments of the universe. Designed to see the universe in infrared light, invisible to our eyes. This allows it to observe objects that are too faint or too distant to be seen in visible light. This golden honeycomb mirror, composed of precisely aligned segments, orbits the Sun 1,000,000 miles from Earth, far beyond the reach of human repair missions, peering into the cold, silent dark, where the first stars and galaxies were born. Unlike Hubble, which saw mostly visible light, providing stunning images of nebulae and galaxies, Webb's infrared vision lets it pierce cosmic dust, which obscures our view in visible light, revealing hidden star nurseries, where new stars are being born within dense clouds of gas and dust, and the faint glow of the first galaxies, formed just after the Big Bang. Why infrared? As the universe expands, light from ancient objects stretches into longer, redder wavelengths, a phenomenon known as redshift, into the infrared. This makes infrared light the key to unlocking the secrets of the early universe. To see the dawn of time, you need infrared eyes. Webb is our golden eye on the cosmos, a technological marvel, built to capture these faint, ancient signals, carrying information from billions of years ago. We aimed it at the darkest patches of sky, regions seemingly devoid of light and matter, searching for the first stars and galaxies, the building blocks of the universe, the seeds of everything we know. We had theories and models for what we'd find, based on decades of research and observation. We were ready to be amazed, to confirm our understanding of the universe's evolution. But we weren't prepared for what Webb actually found. The data it sent back was both breathtaking and perplexing. The universe had a surprise. A puzzle that challenges everything we thought we knew about our cosmic origins. It was a moment of both triumph and profound humility. To truly grasp the significance of Webb's groundbreaking discovery, we need to delve into a fundamental concept. You need to understand what it fundamentally means to look deep into the vast expanse of space. It's not just about seeing farther, it's about seeing back in time. Light, the very messenger that carries images across the cosmos, takes time to travel. It's not instantaneous. When we gaze upon distant galaxies, we aren't seeing them as they are. Instead, we perceive them as they existed millions, even billions of years ago, when the light we're now observing first embarked on its long journey to our telescopes. Webb, with its unparalleled capabilities, effectively lets us look back in time with unprecedented clarity. It allows us to peer into an era when the universe was just a fraction of its current age, a cosmic infant still in its formative stages. In a sense, we're cosmic archaeologists, meticulously digging through layers of time, using light as our primary tool to unearth the secrets of the early universe. Our ultimate quest is to find and understand the cosmic dawn, the pivotal moment when the first stars and galaxies ignited, bringing an end to the universe's long and mysterious dark ages. The intense light from these nascent stars and galaxies burned away the pervasive cosmic fog in a transformative process called reionization, making the universe transparent to light for the first time. Locating and studying these first galaxies represents the holy grail of cosmology, the ultimate prize in our quest to understand the universe's origins. With unwavering determination, we aimed Webb at the farthest reaches of observable space, fully expecting to find relatively small, faint, and somewhat clumpy galaxies, essentially cosmic toddlers in their early stages of development. Our established cosmological models predicted that these primordial galaxies would slowly merge and gradually grow over vast stretches of time, eventually evolving into the grand, well-defined spiral and elliptical galaxies we observe in the universe today. But instead, to our utter astonishment, we found something impossibly grown up, something that defied all expectations. Webb revealed the existence of galaxies that appeared remarkably mature, surprisingly massive, and astonishingly well-formed, existing far earlier in the universe's history than we previously thought possible, challenging our fundamental understanding of galaxy formation. The cosmic dawn, as revealed by Webb, was fundamentally not what we expected it to be. The universe's first light was not faint and diffuse, but rather surprisingly brighter and far more complex than our current models and simulations could adequately explain or even allowed for. This groundbreaking discovery has forced us, as scientists, to critically rethink our entire understanding of the early universe and the processes that governed its evolution. The universe's past, it turns out, was far more surprising, far more dynamic, and far more mysterious than we could have ever imagined. When we peer into the darkest patches of sky, areas seemingly devoid of light and matter, we expect to find, well, nothing. But the universe is full of surprises. The James Webb Space Telescope, with its unprecedented infrared capabilities, pierced through the cosmic veil and found galaxies, but not the tiny, chaotic, and primordial ones we expected to see dotting the early universe. We anticipated observing galactic infants, still in the messy process of formation. Instead, Webb's gaze fell upon massive, bright, incredibly luminous structures, well-formed galaxies exhibiting a level of organization and maturity that defied expectations. Cosmic behemoths, galactic giants that seemed impossibly large for their age. These galaxies were already mature, fully formed, when the universe was just a cosmic toddler, a mere 3 to 4% of its current age. We expected to find small settlements, nascent galactic communities just beginning to coalesce. Webb found bustling metropolises, fully developed galactic cities teeming with stars. These galaxies rivaled the mass of our own Milky Way, a galaxy that has had billions of years to grow and evolve. They were packed, containing billions of stars, each a sun in its own right, illuminating these ancient structures. How could so much matter assemble so quickly, condensing into these colossal structures in the immediate aftermath of the Big Bang? Building a galaxy according to our current understanding is supposed to be a slow and gradual process, requiring gravity to patiently pull vast clouds of gas and dust together over billions of years, a cosmic construction project of immense scale and duration. Webb's discovery sent shockwaves through the astronomical community, challenging long-held beliefs and established models. It wasn't a minor adjustment to existing theories. It was a direct and fundamental challenge to our entire understanding of how the universe builds structure, how galaxies form and evolve. It's like finding a 1,000-page novel, a complex and intricate work of literature written by a toddler. It simply shouldn't be possible. Scientists now faced a profound puzzle, a cosmic enigma that demanded a reevaluation of our fundamental assumptions. Is our understanding of galaxy formation deeply flawed? Are we missing crucial pieces of the puzzle? Or was something else, some unknown mechanism or force at play in the early universe, accelerating the formation of these galactic giants? The evidence captured by the Webb telescope was undeniable, a clear and unambiguous signal from the early universe. The early universe was far more efficient, far more adept at building galaxies than we ever imagined, a cosmic construction zone operating at breakneck speed. The cosmic story, the narrative of the universe's evolution, had taken an unexpected and dramatic turn, revealing a new chapter filled with mystery and wonder. Before Webb, our best model, lambda cold dark matter or lambda CDM, explained the universe's structure through slow, hierarchical growth. The Big Bang left a nearly uniform soup, with tiny density fluctuations. Gravity, aided by invisible cold dark matter, pulled matter into small halos, forming the first protogalaxies. These small galaxies merged over billions of years, building up the massive galaxies we see today. The process was slow and methodical, like building with bricks and mortar. Our models predicted that, at the cosmic dawn, we'd see only these small building blocks, not fully formed galaxies. Webb's discovery forced us to question this entire story. The universe's clock was ticking much faster than we thought. The problem is simple. The universe had limited raw material and time after the Big Bang. Our models set strict limits on how fast gas could turn into stars and galaxies. Webb's ultra-massive early galaxies break this cosmic budget. It's like being given a handful of Lego bricks in 10 minutes, but returning to find a sprawling castle. Something doesn't add up. Maybe star formation was far more efficient, or the first stars, population 3, were colossal and short-lived, seeding the cosmos quickly. But even these tweaks can't fully explain the sheer mass Webb found. It's not just about making stars faster, it's about gathering enough fuel so quickly. Did we get the rules of gravity or the early universe wrong? The conundrum of too big too soon is forcing scientists to reconsider the foundations of our cosmic model. The early universe was a far more dynamic place than we ever imagined. Faced with the impossible, scientists are brainstorming new ideas. Maybe these galaxies aren't as massive as they look. Perhaps they're just unusually bright, with synchronized bursts of star formation. Or maybe we're seeing the glare of supermassive black holes, quasars, making small galaxies appear huge. But that just raises new questions. How did black holes grow so big so fast? Some propose direct collapse black holes. Giant gas clouds collapsing straight into black holes, skipping the star phase. Each theory has strengths and weaknesses, but none fully explains the data. We're like detectives at a crime scene where the clues don't add up. The universe has forced us to consider possibilities we never imagined. The mystery deepens when we consider dark matter. The standard model relies on cold, slow-moving dark matter which clumps easily and builds small halos first. But what if dark matter isn't so cold? If it's warmer, it resists clumping, leading to the rapid formation of massive galaxies. This could explain Webb's skyscraper galaxies, but it risks breaking everything else the model gets right. Scientists are exploring mixed models, tweaking the nature of dark matter. Webb's discovery is more than a galaxy puzzle, it's a clue about the fundamental nature of most of the universe's matter. The universe is running a cosmic experiment, and we're just starting to understand the results. The challenge is to decode the message sent across 13 billion years. The answer could reshape our understanding of dark matter itself. The stakes have never been higher. Webb's discovery has injected humility into science. For decades, our cosmic story seemed complete. Big Bang, cold dark matter, slow growth. We thought Webb would fill in details, not tear a hole in the plot. The universe doesn't owe us simplicity or elegance. Science is a journey into the unknown, and every new answer is a gift. These impossible galaxies aren't a problem, they're an opportunity. They point us toward new physics, and a deeper understanding of our origins. No one has the answer, not even the experts. We're all explorers, standing on the same shore, looking out at a mysterious ocean of data. Theories now are just our first steps into new territory. The real answer may be something no one has imagined yet. The universe is far from finished telling its secrets. Our cherished story of creation is due for a major revision. The cosmos is more mysterious than we ever dreamed. So, where do we go from here? Webb will keep searching, collecting more light from these ancient galaxies. With more data, we'll refine our measurements and test new theories. The first discovery was a shock, but the real work is just beginning. Webb's journey has only started. What other surprises await in the cosmic dawn? We're living through a revolution in our understanding of the universe. You are alive as we take our first clear pictures of the universe's baby album. The story of the cosmos is not finished, it's unfolding page by page. These impossible galaxies are a challenge and a promise. As we point our golden eye to the beginning of time, we must be ready for anything. The cosmic story is just getting interesting.